Okay, we're going to continue with infinite geometric, or with geometric sequences and series. Okay, and so I'm gonna show you how to do this on your calculator. Use the calculator to find the sum of the first 15 terms of this sequence. So to review, the sum of a sequence, the sum of a geometric sequence is S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. Okay? So in this case, the first term, if I plugged in a 1 in here, I don't even, oh, we're not going to use that. We're going to use a calculator. I'm sorry. So we're going to use our calculator, and this is the sequence we're going to use a calculator for. But I could have used this over here as well, but I'm going to come back to this in a minute. So anyway, you're going to go to mode and make sure that you are in sequential mode, which I am. Okay? And actually, I don't even need to be in sequential mode. So I'm just going to go second quit, and then it can be in sequential mode, but it doesn't have to. Okay, so now I'm going to plug in. I'm going to go second stat. It's just like what we did with the arithmetic sequence. Go over here to math and go down here to 5, which is sum. Okay, and the sum, and then I'm going to go second stat and go over here to ops, and again number 5, so that'll give you the sum of the sequence. And then I'm going to type in this, which is I think I have to put another set of parentheses here, so I'm going to go 1 divided by 3 raised to the n. Okay, whoops, that's not a raised to, is it? That looks like a pi. Okay, so I'm going to delete that too. And then I have to close that parentheses, sorry. And then I'm going to go raised to the n, which comes out to be an n because I am in sequential mode. And then I can put comma, evaluating for the variable n. Okay, from 1, whoops, I forgot a comma, from 1 to 15, and I'm going up in increments of 1. That's what that last one means. And then I can close that parentheses. And have I closed all my parentheses? I think some of this sequence, I think, let's see what happens if I hit enter. And that's what I get, 0.499999, which is very close to 1/2, which leads to the next thing, okay? This is the sum of an infinite converging geometric series, okay? What converging means that it eventually hits some concrete number. Like in this one, it appears as if I plugged in bigger and bigger numbers, you would guess that I would approach the number 1/2, okay, based on this particular this sequence, okay. So if I add, in other words, in this one, if I went 1/3 plus the next term, which would be 1/9, plus the next term, which would be 1/27, plus dot 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 on to infinity, 1/3 to the n. Eventually, that would not approach infinity, but it would approach the number 0.5, which doesn't seem to make much sense, but it actually does. Okay, so this formula says, this is kind of scary looking, but all this means is the sum of all the terms. You can find the sum of all the terms of a converging geometric series, and converging ones you can tell by if the numbers that you're adding are getting smaller and smaller and smaller. Okay, that's how you tell if it's converging, basically. But in any case, if I were to plug, this formula comes out of the fact that if I were to plug in a number, a very big number in here, this number, 1 minus r to the infinity, if this number is less than 1, like 1/2, this number approaches 0. So you get a 1 on the top, and a sub 1 times 1, that is just a. Okay, so this is the starting value. This should really be an a sub 1 right there. Okay, so in this case, for instance, say I wanted to find what value this approaches, okay, or what the sum of this infinite series. So if I did this, I would put a sub 1, which would be 1/3 on top, over 1 minus 1/3 on the bottom, okay, which is 1/3 over 2/3, and those go away, and I get that indeed this does approach 1/2, okay? So if I added up all the terms of this particular sequence up here, okay, I would get 1/2. And by the way, the difference between a series and a sequence is the sum of a sequence. So when I add up all the terms of a series, of a sequence, I get a series, okay? So doing this one, I get the first term is 2, and it appears to find r, in this case, what I'd have to do is divide this by this, because remember, I'm multiplying by something from here to here to get this. Okay, the easiest thing to do might be to just look at this. 4 times 2 will give you 8. 3 times 3 will give you 9. So the thing that I'm multiplying by is 2/3. Or I could take 4/3 and divide that by 2, which is the same as multiplying by 1/2. So I get that r is equal to 4/6, which is equal to 2/3. Okay, so that's r. And the way I got that is dividing this by this. All right, so now I know that r is 2/3, and my starting number is 2, right? And so I get 2 over 1 minus 2/3, which is 2 over 1/3, 2 over 1/3, which is the same as 6. And so if I added all these terms all the way to the like, this would be like some, you can find out what the, you know, all the way to infinity, no matter how far I went, those would just add up to 6. Okay? Now, using this idea, show that the repeating decimal 0.9999 equals 1. What I could do with that is write this as a converging geometric series. So I could write 0.999 as 9 over 10, because this is 9/10, plus 9 over 100, plus 9 over 1,000, right? Because this is 9 1,000ths, plus dot, 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 9 over, what would that be? 9 over 10 to the n, 10 to the n, right? And so that this is equal to 1, well, r in this case appears to be, you can see that I'm multiplying by 1/10 each time. So r is 1/10, okay? And the starting value is 9/10. So using this formula up here, I get 9/10 divided by 1 minus 1/10, which equals to 9/10 divided by 9/10, which is actually equal to 1. Okay? So this repeating decimal, if I go on forever and ever, we have just proven that that is equal to 1, which is kind of weird. Anyway, but interesting. Okay, so now we're going to go to this word problem down here. And I'm going to hide this. I'm going to hide this. I'm going to hide that. How am I going to do that? There we go. And I'm going to go down to this. Okay, and this is just a geometric sequence as well. Initially, a pendulum swings through an arc of 18 inches. On each successive swing, the length of the arc is 0.9 times the previous arc. So in this case, you want to start by writing the very first term of the sequence, which is 18, right? And the next thing is 0.98 times 18, okay, and so on and so forth, okay? What is the length of the arc on the 10th swing? So in that case, what I could use is the formula a sub n, the explicit formula, is equal to a sub 1 times drawing a blank here, times r to the n minus 1, okay? And in this case, it's pretty obvious that r is 0.98 because that's what I'm multiplying by each time, okay? So if I want the 10th term, which is a sub 10, I would plug in the first term, which is 18, times 0.98 to the 9, because that's 10 minus 1, and I will get some answer, okay? And let's see if I could do that on my calculator, if I could get back to my calculator here, okay? Then I'm gonna go back to what I had up there. There we go. And so on my calculator, I'm going to plug in 0.98 raised to the 9th. I kind of want to do that first. And I'm going to times that, enter, times 18, and I will get 15.07. Okay, so after the 10th swing, the length of the arc that it swung through is 15.007 inches. Okay, on which swing is the length of the arc first less than 12 inches? Okay, so the way I would do that is I would set, I guess what I want to do with that is plug this into a, so I'm back. So the way I would set this one up, I'm going to set this equal to 12, 18 times 0.98 raised to the n minus 1, and then I'm going to divide both sides by 18. So I get 0.98 raised to the n minus 1 equals, I guess you could do this with your calculator, but I like to do things algebraically, equals 12 over 18, which I think reduces to 2 goes in there, 6/9, which is, oh, that's 2/3, isn't it? Okay. So then, if you remember from actually a while back, I can take the log of both sides, or the natural log of both sides, and bring that in front. So I get n minus 1 natural log of 0.98 equals natural log of 2/3, right? And then if I divide the natural log of 2/3 by the natural log of 0.98 and add 1 to it, let's try that. ln, clear, ln of 2 divided by 3 divided by ln of point, oh, that's not point, yeah, it is 0.98, 0.98, okay, plus 1, let's first divide it, and then, go to, what did I do wrong? ln of 2/3, I don't think I need this parentheses here, do I? ln of, delete, ln of 2/3 divided by ln of 0.98, let's see what happens now. I get 20.06 plus 1, okay, and I get 21. So sometime after the 21st swing, it would be swinging less than 12. So after 21 swings, it would be less than 12. After 15 swings, what would the total distance will the pendulum have swung? Okay, so okay. Moving on, I'm going to use this formula here to figure out this problem, because this gives you the sum of a geometric sequence. Okay, so I would go 1 minus 0.98 raised to the 15. Okay, because r is 15 and n is 15 and r is 0.98, divided by 1 minus 0.98, which would give a 0.02 down there, I believe. Okay, so after 15 swings, let's see if I could do that over here. 1 minus 0.98 raised to the 15th equals, divided by 0.02, and I get 13.07 after 15 swings. That doesn't make sense, does it? What is it? Pendulum will have swung after 15 swings? How could it only have swung? Pause. Okay, I'm back. So I just forgot to multiply this by a sub 1, and a sub 1 is the length of the first swing, which is 18. So if I take this number and multiply it by 18, now I get that after 15 swings, you would have gone through a total swinging distance of 235.28 inches. That's a point right there, and that's a typo right there. Let's see if we could get rid of that. There we go, inches. All right, and then when it stops, was the total distance the pendulum would have swung? Well, then I'm going to use my formula that the sum for an infinite, because this is it's a converging sequence because it's going down each time. So this would just be a sub 1, which is 18, over 1 minus r, which is 0.98, which is 18 divided by 0.02, which gives you 18 divided by 0.02, and you get 900 inches. Okay, and I know that's kind of weird that when it stops, because it keeps going on forever and ever, but in actuality you come up with a finite distance that pendulum would have swung for. And I think it's kind of confusing, because when the pendulum swings, it swings like this and then it swings back, but I think in this particular problem they're talking about each swing being one side or the other. So this is considered the first swing, and the second swing is a little lower, and the third swing is a little lower, like this. So it's kind of going like that back and forth until it stops, and it would have gone 900. I believe that's what they're talking about. Okay, so in any case, that's your homework. Have fun. That's kind of messy, so I'll erase that, and stay tuned for more exciting days of math lectures and funny jokes in Mr. Leader's class. Goodbye.